All right, so let's take a look at this question together. You have these equations, and you have the values here written out for you. So your initial height is 3.5. Your initial speed, it's 140, and your theta is 20 degrees. So your x equation would be, what is it? 140, and then cosine of 20 degrees times t. Your y equation would be negative 16t squared plus 140, and then sine of 20 degrees t, and then plus 3.5. Okay, so those are the two equations that you would put it into your calculator. And on the calculator, again, you would go to the option, you go to graph entry edit, and then you choose parametric. So for parametric equation, you would type in your 140 cosine of 20 degrees, and then don't forget a variable t, and then go to the next line, go negative 16t squared, and then plus 140 sine of 20 degrees, and then don't forget the t variable. Make sure you are not only focusing on the numbers, but the variable as well, and the final y0 will be 3.5. So so that is the function, and I want to make sure that my angle is in degree mode. And then my graph, it's not really showing me the whole picture. So I have to go to my Windows settings, and I'm going to be more aggressive. I'm going to say, let's go ahead all the way to 50. And this is going to be 500. And let's just try my luck here. And well, it seems like, oh, I actually got the wrong setting. I should say x max is 500. Well, x max is 500, y max is 50. So now it's much better. All right, so you play with the Windows setting, you get your whole graph, and then we say, all right, let's go ahead and plot it. Okay, we can go ahead and plot the graph. So this is 3.5, and it goes up and down like this. So we are likely to be very interested in the top point and the x-intercept. So that's going to be the questions for part C and part D. So to find out the maximum height, we will go to the graph and we say, let's go ahead and trace it. All right, let's go ahead and trace the graph. So we go to trace, graph trace. Again, by default, the step size for time, it's going to be 0.1. So we'll use that step size to get closer to the maximum. And right around there, we will adjust our step size so that we can be more accurate. So 0.01. Okay, so you pay attention to the y value to see if you get the maximum y value. So for 32.2, 39.5, no, 39.3, sorry. So 39.3 is the height that I'm getting here. So it seems like the maximum height is 39.3. So so if you can get me something like 1.5, I would take it. Somewhere close to time equals to 1.5, I will take it. So time equals to 1.5. This point is 197, comma 39.3. Okay, 197 and 39.3. Okay, so so we'll say, what's the maximum height of the baseball? That would be the maximum height. Would be maximum height would be 39.3 feet. And then what time would it reach the maximum? The time would be 1.5 seconds. And then what is the distance? Horizontal distance would be x equals to 197 feet. Okay, all from the graphing calculator. And when would it hit the ground? Well, when would it hit the ground? We will have to trace again. So again, we will want to have a bigger step size so that we can trace faster. And then we can say, all right, let's go fast. Let's go fast. Go, 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 go. All right, so somewhere close to here. And then adjusting the step size to 0.01. All right, so this is the closest I can get. Let me see if I can get to, would it entertain me if I do one more digit? All right, so I think this is really good. So around 3.06, okay. So so around 3.06, I get 403, comma 0.003. Okay. So at t equals to 3.06, I got 403, comma 0.003. So now one disclaimer, and that is my step size was very small. And the t is only showing 3.06, so only to the 100th of a second. So so you may get 3.06 and you may get something different. So it's okay. My goal is that you can get the y value as close to 0 as possible. That's my goal. Okay. So when would it hit the ground? Time is equal to 3.06 seconds. And how far is this from Jackie in the horizontal direction? So x equal to 403 feet. Okay, 403 feet. All right, so that's part D. And would it clear? Would it clear? Would it clear the? Would it clear a 20 feet wall that is 300 feet, 350 feet away? Okay, would it clear a 20 feet wall that is 350 feet away? So that means we want to find out where it is at x equals to 350. So again, I need to readjust my step size so that I can walk faster. To x equals to 350. So so here, I'm going to say 0.01. So at 350, the ball is at 17.7 feet high. So we will say, well, at what time? At 2.66 seconds. Okay. When the ball is 350 feet away, the ball's height is how high again? 17.7. 17.7 feet. So close to 20, but no. So so no, okay. It will not clear the 20-foot wall in this case. Okay. So again, it's all about your ability to trace. And how can you trace in a more accurate way? How do you trace in such a way that you know how to interpret your x value, your y value, so they can obtain the right answer?